started with section 4.1. Section 4.1 we'll be talking about what are called integer exponents. Now, a couple of things I just want to break down before we get started. An integer is just a number without fractions or decimals. Another way to think about an integer is it's a whole number and their opposites. So an integer would be like -3, -2, -1, 0, 1, 2, 3, and so on. That's what we're talking about when we're talking about integers. And an exponent is just the same thing as a power. So if we have a to the base n power, a is called the base, and n is what we're referring to whenever I say power or exponent. Just so we're all on the same page with vocabulary. So to get started first, I wanted to talk about what's called the product rule. The product rule just says if you have the same base and you're multiplying them, what you do is you add their exponents. So let's go through some examples. I'll ask you to simplify. Jonathan. It's okay. Let's say we had 2 to the third times 2 to the second. Okay. According to our rule, because we do have the same base of 2, the answer would just be 2 to the 3 plus 2 power, or just 2 to the 5th, which I believe is 32. You could either say 2 to the 5th or you could say 32, that's fine. We'll do some harder ones. What if I asked you to do m to the 8th times m to the 6th times m? What we want to do is we want to add all of those exponents. It looks like that third m doesn't have an exponent though. What would the power of that third m be? Would that be 0 or 1? 1, of course, right? So when we go to add these, we're going to say m to the 8 plus 6 plus 1, which is the same thing as 15. All right, what about if we had some different variables? What if we had -5 p to the 4th times -9 p to the 5th? I'm not really sure. If you guys want to participate, you could just yell it out. I'm just saying, hypothetically, if we had this, what do you think? Sometimes I talk to myself. It's nice if you guys talk to me. That's exactly right. All right. So what we could do, one thing we could do is called the commutative property. This is something that people have learned at some point in middle school and they've never actually known how to apply it. One thing that's easy for this is if we're multiplying, it doesn't matter what order we multiply them in. We could just do -5 times -9 times p to the 4th times p to the 5th. So sometimes it's easier for people to rearrange them and group them by similar grouping. So -5 times -9 is just 45, and then we have p to the 9th. If you could also do that without rearranging, that's great, but we do have that extra property to make things a little bit easier for us. And then the hardest kind of problem we could see with these is if we had -3 x to the second y to the third times 7x y to the fourth. If you want to just multiply the numbers together, multiply the x's together and the y's together, that's totally fine. You could skip a step. What I'm going to do is I like grouping the similar terms. So I'm just going to do -3 times 7. I'll do x squared times x, and then I'll do y to the third times y to the fourth. It's one extra step, but I found the more steps that I show, the less likely I am to make mistakes. -3 times 7 is -21. X to the third, y to the seventh. So those are all examples of what's called the product rule. The next rule I wanted to talk about is called the zero exponent rule. The zero exponent rule says anytime you have a base to the 0 power, the answer is 1. So again, the directions will be to simplify. And if we just had 29 to the 0 power, of course, we would say the answer is 1. If we had -29 to the 0 power, the answer is 1. But what about if we didn't put parentheses and we just said -29 to the 0 power? How do you know it's -1? So that is correct. With this problem, the answer would be -1, because really what this is saying is it's saying -1 times 29 to the 0 power. If you don't have that negative and the 29 together, you're just raising the 29 to the 0 power, not the negative. So 29 to the 0 power is 1. -1 times 1 is just -1. So just be careful of those. That's a common mistake people make. And then what about -29x to the 0 power? Obviously, that whole thing is being raised to the 0, which is just 1. And then to finish, what if you had 8 to the 0 minus 15 to the 0? It would be 0. This would just turn into 1. This would be 1. 1 minus 1 is 0. So that's good. We could apply these rules in isolation. The tricky part is when you have a problem and you have to do 3 or 4 different rules at the same time. We'll kind of build up to that point. The next rule is called the negative exponent rule. And this just tells you if you have a negative exponent, you switch the position of it to make it positive. We never want to have negative exponents. So if you have a negative exponent, you could either switch it to the bottom if it's on top of a fraction, or if you have a negative exponent on the bottom of a fraction, you just bring it up and it becomes positive. Go through some of these examples. This one be an example. So let's take a look at some examples for this. Again, we'll just be simplifying. Let's say 6 to the -5th. If you were to type that into your calculator, you'd get a decimal. But what we want is we want to write this 1/6 to the 5th. That's a good enough answer. Just leave that alone. Similarly, if you had 10 to the negative 1st, you just switch the position, make it into a fraction, and then bring it to the bottom. This would be 1/10 to the 1st, or just 1/10. What if we had 2x to the negative 4th? In this case, that whole grouping is being raised to a negative power. So what we want is we want to write this 1/2x to the 4th. We could even distribute this 4th power and write this 1/2 to the 4th times x to the 4th, which is 16x to the 4th would be the best answer. We'll do one more of these. What if we had -7 times p to the negative 4th? Anyone know how to simplify this? Something goes to the bottom. Just the p. The -7 is really -7 to the 1st power. We just want to move whatever variables have a negative exponent. So the -7 would just stay where it is. The p to the negative 4th would go to the bottom. So that would be the answer. You don't even have to write the 1st power over here. So that's looking at negative exponents. What I wanted to try to do now is do combinations. So what if we had other examples where I still am asking you to simplify, but what if it's 4 to the negative 1st minus 2 to the negative 1st? We don't really use decimals from this math level on up to pre-calculus and calculus. We don't use decimals anymore. We usually keep everything with fractions. So this first 4 to the negative 1st is just 1/4 minus 1/2. Just bring them to the denominator, and then you just get a common denominator to simplify. So 1/4 minus 2/4 is -1/4. What if we had 1/4 to the negative 3rd? Yeah, you just bring this to the top, and this would just be 4 to the 3rd, which is 64. And then if we had 3 to the negative 3rd over 9 to the negative 1st, you just swap them, right? In algebra, it always just comes down to rules. If you follow the rules, you'll get the right answer. So this is a negative power, we'll bring it down. This is a negative power, we'll bring it up. So we wind up with 9 to the 1st divided by 3 to the 3rd. 9/27 is just 1/3. Just follow the rules. Next property I wanted to talk about is called the quotient rule. Generally in math, you have opposites. You have addition, you have subtraction, you have multiplication and division. With the quotient rule, when you multiply the same base, we add the exponents. So when you divide the same base, you subtract the exponents. That's what the quotient rule says. We'll go through some examples of this. So let's simplify m to the 13th divided by m to the 8th. They are the same base, so we could just subtract their powers. And this would just be m to the 5th. What about x to the 4th divided by x to the negative 2nd? You can move the negative 2 on top. Another thing we could do is just use the quotient property. What's 4 minus negative 2? 6. So even if you bring it on top, you're just going to do 4 plus 2. It works the same exact way with this. So 4 minus negative 2 is still 6. We're having some technical difficulties in class. There's a noise I'm trying to take care of, but unsuccessfully, I guess. And we'll just do one more example like this. If we had 5 to the negative 8th divided by 5 to the negative 6th. What we would do is we would just say 5 to the negative 8 minus negative 6. Negative 8 plus 6 is negative 2nd. And then we would just write 1 over 5 to the 2nd, or just 1 over 25. Put in an email and get that taken care of. So that's using the quotient rule. There are some other rules called the power rules. And there's 3 of them. One of the power rules says a power of a power, which would be like if you had a to the m to the n power, you would just multiply those exponents. We also have a power of a product, which would be a times b to the m power. And in this case, you would distribute the m to each exponent. This would be a to the m, b to the m. Which I'd actually like to change this, if you guys don't mind. If you already wrote that down, that's fine. I don't want you to mess up your notes. But that's what the book says. I'd like to give you a better definition. If you had a to the x power, b to the y power, and you're raising this to the m power, you would actually distribute exponents. I think it's a little bit more clear to write this a to the xm power times b to the ym power. And then the third power rule says a power of a quotient. The power of a quotient says if you had a to the x power divided by b to the y power all to the m, you would just distribute the exponents. So a to the xm divided by b to the ym. And we'll do a few examples to practice this. Okay, so let's do some examples. The directions will be to simplify. And say if we had r to the 5th to the 4th power, you would just do r to the 20th. 5 times 4 is 20. That's an easy example. What if we had negative 3 y to the 5th to the 2nd power? What we would do is we would distribute this to each term. So this would be the same thing as negative 3 to the 2nd times y to the 5th to the 2nd. Negative 3 to the 2nd is 9. Y to the 5th to the 2nd is y to the 10th. So you can see we're having to use multiple properties for some of these problems now. What if we had x to the 2nd divided by y to the negative 3rd, all to the negative 2nd power? Well, just like before, what we're going to do is we're going to distribute this negative 2 to the exponents. This would be the same thing as x to the negative 4th over y to the 6th. And then we could just drop this x to the bottom and say 1 over x to the 4th, y to the 6th. I'll do one more. What if we had negative 3 n to the 4th over m to the 2nd, all to the 3rd? You want to distribute the 3 to the exponents. So this would just be negative 3 to the 3rd times n to the 4th to the 3rd over m to the 2nd to the 3rd, which would be negative 27 n to the 12th over m to the 6th. Yeah. You only put the n in you only switch positions if the exponent is negative. So because we don't have negative exponents, everything stays where it goes, right? We're only concerned about the exponent being negative. If the leading coefficient's negative, it has nothing to do with it. We just leave it alone, right? You're welcome. All right. What if we had something like this? We'll call it negative exponents and fractions. So a couple properties look like this. One of them says a to the negative n power. We talked about being 1 over a to the n. It's also the same thing as 1 over a to the n power. So just a couple different ways to look at it. And another property is if you have a over b to the negative n, one thing we could do is we could write b over a to the n, so just switch them and make the exponent positive. Or we could just say a to the n over b to the n, and then switch them. So sometimes there are a few different ways to use the formulas. We'll finish up with a few examples, and then we'll move on to the next section. Again, the directions will be to simplify. What if we had 2/3 to the negative 4th power? Yeah, so there's a couple different ways we could do this. One way we could do this is to say 3 over 2 to the positive 4 power. Another way we could do this is we could say 2 to the negative 4th over, 3 to the negative 4th. Wait a minute. I'm not sorry. 2 to the negative 4th over 3 to the negative 4th. So there's a couple different ways we could do this. In the end, we'll still wind up with the same answer. Using this first technique where we switch and change the polarity of the exponent, 3 to the 4th over 2 to the 4th is just 81 over 16. That's if you take care of the negative and then the exponent. Doing the other way that we've talked about, you could switch them, and of course you wind up with the same answer. So sometimes in math you have options which with whatever way you feel comfortable with. It might be different from the person next to you, or it might even be different than what I want to do. As long as you apply the rules properly, everything's fine. What about if we had 1 over 2x to the negative 5th power? We're going to do, so we could do this a few different ways. One way we could do it is just to switch from the start. So 2x over 1 and make this to the 5th power. And then 2 to the 5th, x to the 5th would just be 32x to the 5th. That might be the fastest way to do this. And I have a few just mixed to review in here. What if we had 4 to the 2nd to the negative 5th power? This would be the same thing as 4 to the negative 10th, or just 1 over 4 to the 10th. X to the negative 4th, x to the negative 6th, and x to the 8th. If you're multiplying all the same base, the rule is that you add them. Negative 4 plus negative 6 is negative 10, plus 8 is negative 2. That's one property. And then we have another property that says we write 1 over x to the second. It depends. So 4 to the 10th is a really big number. It's fine if you just want to write 4 to the 10th. It's also fine if you want to do it. If it's a small number, like if it's 2 to the 3rd or 2 to the 4th, typically we write that out like you're saying. But if it's going to be a big number, 4 to the 10th, if you want, you could say this is 1 over 10, 4, 8, 5, 7, 6. But, typically, this is the standard way to write it, but this is also correct. I guess to answer your question, if when you do the exponent, if it's a number that's smaller than 100, then we usually do it all the way, like 2 to the 3rd. But if it's going to be a big number, it's standard just to write it 4 to that power. Does that make sense? All right. There's no real hard rule for that. On the test for this, if I was going to give this to you, it would probably be 1 over 2 to the 3rd, which you could leave it like that, or you could write 1 over 8. I'd accept either one. Okay. It's a fair question because it does seem inconsistent, right? Sometimes you leave it and sometimes you don't. What about if we had this? M to the second n to the negative second power divided by m to the negative 3rd times n. This one has 3 properties in it. I would go ahead and remember the PEMDAS. Please excuse my dear Aunt Sally. I would go ahead and deal with parentheses and exponents first. So I distribute this negative 2, which would be m to the negative 4th, n to the negative 2nd, over m to the negative 3rd, n to the 1st. Then you could swap everything, but you could also just subtract the exponents. So what would m to the negative 4th divided by m to the negative 3rd be? So remember, we're subtracting. Negative 4 minus negative 3 would be negative 1. Negative 2 minus 1 would be negative 3. So for your final answer, you would just put those on the bottom. Absolutely. Let's see if we get the same answer. You should, as long as you're following the rules correctly. So if we swap them, this would be m to the 3rd over m to the 4th. And then we would have n to the 1st is here, n to the 2nd is here. So let's just see if this all works out. M to the 3rd divided by m to the 4th would be m to the negative 1st times 1 over n to the 3rd, which is exactly the same answer. Does that make sense? It could get confusing because there's a lot of moving pieces here. But does anyone have any questions with this? No. It's also fine if you have some what if questions, what if this were the case? What if this were the case? Just ask me and I'll try to answer them. I have one more problem from this section that I think wraps everything up for us. What if we had 2y over x to the third to the second power times 4y over x to the negative first? So I see a few of you go ahead and get started on it. That's great. You don't have to wait for me to do it. What I would do first is I would distribute the exponents. So I would deal with my exponents in parentheses first. So this first fraction becomes 2 to the second, y to the second, over x to the sixth. That second fraction turns into 4 to the negative first, y to the negative first, over x to the negative first. From here, what I would do is I would just get organized. So there are a few different ways to finish this. I know 2 to the second is 4. The y squared is fine. The x to the sixth is fine. So the first fraction, I got rid of the negative powers. For the second fraction, I'm going to bring the 4 down. I'm going to bring the y down, and I'm going to bring this x up. So we had to handle the power of a fraction rule. We also had to deal with the negative exponent rule. And now if we just multiply straight across, that's how we multiply fractions. We get 4xy squared divided by 4x to the sixth y. So if you break it down into smaller pieces, we get this. 4 divided by 4 is just 1. What's x to the first divided by x to the sixth? Negative fifth, very good. And then this would be y to the first. So we have to bring the x to the bottom, giving us just the answer y to the first over x to the fifth.